Welcome to Tetryonics Quantum Gravity or Gravitation. In this lecture we'll be discussing the unification of Newtonian gravity with Einstein's general relativity through the quantum field effects or field geometry of equilateral energy. All of the material in this book or this presentation is contained in the fourth Tetryonics book, Quantum Cosmology, which is available on the web or Pirate Bay or YouTube through various other sources. Today's information can all be obtained from the Google Drive, obviously, as we do this presentation, and I welcome any questions that you have as we go through this. We'll start with the spatial geometries of time as defined with relativity and applied back to the equilateral energy of Tetryonics. In the case of charge or bosons, the speed of propagation of energy is a linear direction or creates a line, a vector line in one dimension, moving from the source point outwards to its final point per unit of time. This is indicated on the top left hand side as a vector direction of c. In the case of relativity, all the measurements are based on the speed of light or the speed of energy in a vacuum, and in the case of photons are bidirectional radiant energy forms formed of two bosons, plus and minus charge, radiating in opposed directions. The consequence of this is that if you were to measure or map the geometry formed by light radiating in any unit of time, it will form a spherical geometry around the energy itself, as indicated here with seconds as a planar measurement of c squared per in this case per second. The two are in fact equivalent. C squared is 1 second and 1 second is c squared, depending on whether you're using classical physics or whether you're going to use the relativistic physics of Einstein in his general relativity. In either case, the units must be defined and used appropriately. We can of course define Cartesian geometry using the same method of the propagation of energy in the x, y and z directions, forming cubic C geometries, but more than likely, as we measure it via the propagation of light in horizontal and vertical directions, we measure it as a spherical volume of space created by two light circles, or c squared by c squared, in which case we have a quadrature or a quaternion C geometry, a sphere, in which to measure the energy content within that region of space. And that energy content can be either energy itself, it can be charge, it can be matter. In the case of Einstein's formulation of general relativity, mass, energy and matter were all lumped together and into the stress energy tensor, and just all his works reflect the density of the energy in its various forms within that c to the fourth spherical geometry or spatial geometry. The spatial coordinate systems then are obviously, in the case of measuring mass as well as matter, can either be a cubic measurement or a Cartesian space-time coordinate system, or we can use a spherical c to the fourth space-time system, which is the preferred one for tetrayonic space-time. By using this coordinate system, we're going to obviously use trilinear spatial coordinates instead of rectilinear used in the Cartesian system. The trilinear obviously affording us the ability to physically draw the geometry of the energy in its electromagnetic forms as well as its mass forms and its matter forms as an accurate representation within the coordinate system. It also allows us, c to the fourth spatial geometry also allows us the ability to rationalize our units of time in relativistic equations back to c to the fourth, with c to the fourth being the spatial coordinate system created when you have two masses that are superpositioned, i.e. Two charge fields lying on top of one another are both c squared individually, but when superpositioned they create a c to the fourth geometry that allows us to rationalize energy and superpositioned energy, particularly with matter in its interaction in quantum gravitation. This will be discussed further along. As shown in electrodynamics to a great extent and hinted on in quantum mechanics, any measurement of charge, or be it coulombs or be it amperes, one being the inverse of the other, is simply a measurement of mass per unit of time. In the case of charge, we've already shown that charge is simply the quantized angular geometry of energy measured per second. When you do the algebra on the angular momentum per c squared using relativistic terms for seconds, you find that quantized angular momentum, square meters per second, multiplied by seconds squared per meter squared, or divided by c squared, will give you the classical unit of time. So the equilateral energy geometry of Tetryonic quantum mechanics now defines our measurements of time. In relativity, it's often noted that there are plus and minus time solutions to the relativistic field equations. Tetryonics now shows that the plus and minus time solutions are simply measurements of plus and minus charge per c squared geometry, or per second. So the quantized angular momentum that's present within the geometry at any moment gives us a measurement of time within that area, within that region. Obviously, any measurement of time is simply a measurement of energy movement within a region. If there was no movement of energy within a region in any of its forms, we'd have nothing to detect that anything had changed. So in the case of Tetryonics, we boil it right back down to the fact that time is a measurement of quantized angular momentum, or the geometry of energy, and any measurement we have of time is purely, what we're doing is purely measuring changes to the energy geometry within the region that we've designated per unit of time, or per geometric volume of space. So accordingly, the space-time fields can measure planar electromagnetic masses, be they bosons, charges, energy, photons. Equally, matter itself, which is just a volumetric or a 3D standing wave energy form, can be measured within the same c to the fourth geometries. And as noted in the previous lectures, if you see c to the fourth in the circumscribed circle around any energy geometry, you know that it's a measurement of the matter of that geometry versus a measure of the mass of that geometry. The difference being obviously c squared. Mass is related to matter through the square of light, exactly the same as mass is related to energy, or equated to energy, through the square of light. The terms mass and matter, as we've noted in the previous lectures, are completely distinct terms and should never be interchanged one for the other within physics statements, or indeed within physics illustrations. That's been the cause of a lot of problems with physics so far as defining physical systems and having a rigid framework on which to develop new physics. The exploration has been historically done through mathematics, with many terms becoming confused or deemed ambiguous as to their specific meaning. Geometry removes that ambiguity and shows you the physical relationships of mathematical terms to their geometry. In the case of the universe itself, its geometry can now be determined as being a flat geometry or Euclidean of 180 degrees or pi radians. Any number of pi radian energy geometry make up the universe. This can be quickly calculated back from the mass matter content of the universe at any time as measured, and just solving for the energy content through the c² relationship between mass, or the c⁴ relationship in the case of matter. We can now move away completely from the rectilinear coordinate system of Cartesian's geometry and move into the trilinear or the Tetrayonic coordinate system, where we can draw things using trilinear graphing paper or geometries in order to represent, or best represent, the equilateral geometry of mass energies and matter standing waves within any region of space. Using light or biradial propagation of light at any point, we can quickly redraw the light cone. That's familiar to most people doing relativity in the terms of mass and energy, or mass and matter. It's a biradial radiation of energy from a point, as indicated at the top there. Below that is the geometry of photons, or again EM waves, as they radiate out and measured in frequencies, or 2 pi or 2 quanta charged geometries. Energy itself, it should be noted, when it radiates out, has no spherical geometries around it, because there are no time measurements of c² for mass or c⁴ for matter content. Were it the case that you wish to measure the mass content of photonic energy as it radiates out, as illustrated in the center of the diagram, you would of course take c² time measurements, or second time measurements per second of that energy as it propagates out from the point, and you would obtain the geometry shown on the right hand side of the drawing for mass. On the left hand side, you can actually see that by using c⁴ measurements, they would give us measurements of matter. Same amount of energy, different results due to the relationship of c² between mass and matter. And again, c² for mass and energy, c⁴ for matter and energy. The clear and strict definition between mass and matter and energy within the Tetryonic geometries allows us to clearly define all forms of energy and take them out of being in a stress energy tensor and apply the Tetryonic geometry of each to their interactions. Space-time itself, as in the 3 dimensions of space, can now be defined with the charged geometry of matter. We obviously have x, y and z components, normally mapped out as 3 planes in a Cartesian drawing, giving us the 3 dimensions of space that we measure things in, or energy within that space. Tetryonics, using plus or minus angular momenta per unit of time, obviously form the geometry of all matter. In the case of a icosahedron, as illustrated there on the right of the boxed illustration, each corner or each apex of the triangles that make up the 20 fascia of an icosahedron can actually form the 3 planes of 3-dimensional space. So the icosahedron can now be redefined as a quick reference for, or a summary illustration, a symbol if you like, of 3-dimensional space. This can then be applied back to ancient platonic symbols or solids, things like that. And we can move on. We can now say that the energy and the equilateral geometry of that energy forms time, plus and minus charges, and mass energy. So we now have a definition of space as in the 3 dimensions, and time, i.e. it should be more appropriately retermed the other way, because it's the charged geometry of matter, the charged seconds, or the charged plus and minus charge that creates the 3D volume of matter within any and the 3 dimensions of matter itself within any measurement of a spatial region. Tetryonics, as we've mentioned time and time again, and we'll probably continue to mention time and time again, strictly define the difference between mass, energy, and matter through the equilateral geometry of charge or time, as indicated at the bottom left of this picture. The positive and minus charged equilateral geometries of Planck's constant give us the foundational quanta and geometry of all matter. So in the case of two-dimensional or Euclidean masses, the left-hand side of this illustration shows the charge of mass energy in orange to highlight that it's always a charge, the one side being a positive, the opposite side being negative, and vice versa, generically drawn as an electric field and a magnetic dipole within that equilateral geometry. Of course, the square root of the square energies is the linear momenta within that system. All bosons and energy have this equilateral geometry. Photons themselves are 2π geometries, or 2 mass geometries, where one is positive and the second mass is negative, radiating bilaterally within that same geometry. In the case of energy, as we've mentioned, as indicated in the middle of this diagram, there is no time measurement around the energy itself. It is exactly the same as the mass measurement of the system. However, there is no unit of time associated with it to create the unit of mass. Once energy forms into a standing wave in the form of tetrahedral matter or tetrons, the geometry on the right hand side of the page emerges, where you'll always see it designated as T-pi geometries or Tetryonic geometries per c to the fourth, or quaternion spatial geometries. From these 3 strict definitions of mass, energy, and matter, we can now go on and start investigating quantum gravitation and what it is about standing wave forms of energy that creates gravity. In the case of energy creating a standing wave, the simplest way is through the weak force interaction, is for the 4 sides of a 4π mass to become folded into a standing wave geometry as illustrated there, so that the energy content, or the stress energy in the case of Einstein's formulation, is spread out in a standing wave geometry of matter, or T-pi as Tetryonics refers to it. T-pi energy, as written on the bottom there, is simply matter, and it's always measured per c to the fourth in the way of spatial geometries, because it has volume. Of note is the fact that the 4 energy fields that make up the standing wave of matter form a empty space within the geometry of matter itself. This empty space has been termed null space in Tetryonics, because it's the only place within the universe where absolutely no energy exists in any form. It's a quantum Faraday cage. Any energy attempting to try and penetrate into that null space will be absorbed by the energy fascia, the charged energy fascia of the matter itself in the tetrahedral form, and become just part of its mass, part of the mass of matter. So within every quanta or every tetryon of matter, there is a region of absolutely zero energy, and it's that zero energy spatial region that creates the inward or the convergent force of gravitation. In this case, the vacuum energy outside the standing wave matter geometry that's impinging on that geometry will try, under the second law of Tetryonics, all energy seeks equilibrium, will try to equalize or get rid of that lower energy region by filling it. It will continue to push in on that region of empty space for as long as that region of empty space exists. The only way you can get rid of that region of empty space is for the matter geometry to collapse from its standing wave geometry back down into its radiant energy geometry or mass energy geometry. Light, charge, pure energy. This is just a quick illustration of an electron rotating within a hydrogen or deuterium nuclei. And again, if you were to measure or mark one of the three, or one of the 6 magnetic poles on the three rotor quantum geometry of an electron and map it around its 360 degree rotation, you would quickly see that it creates a sine wave, obviously, but it would also reveal that historically, by not realizing the geometry or the charged energy geometry, EM fields that make up electrons, you would have detected 3 rotations of the electron within the same unit of time. Again, just another stylized illustration of how Tetrayonic geometry can be applied to many things in ancient physics and in metaphysics. The important bit here is that all energy and measurements of space and time can be broken right back down in Tetryonics to measurements of angular momenta and the scalar energy content of that angular momenta. In the case of angular momenta itself, as illustrated at the top right, we designate that with an alpha symbol, because, as noted on the right, alpha per unit of time gives us measurements of charge and measurements of time. Again, as highlighted in Tetryonic electrodynamics, the relationship between wavelength and frequency, given as the constant c, can be revealed to be measurements of quantized angular momentum per c, or per linear unit of measurement, multiplied by the scalar content, or how many quantized angular momenta or quanta are in that same equilateral geometry. If you do the algebra as noted on the bottom there for momentum, you can quickly see that the momentum of any superpositioned energy field, positive and negative in this case, will give you a constant of c. Again, if you calculate for the mass for the momenta, you'll see that it's mass times c for pure energy radiating out. Same thing applies to photons, which are 2π geometries, as is the energy contained within matter. It's always radiating or propagating at the velocity of c within the standing wave of matter. Energy itself is not completely, space itself is not completely empty. All matter radiates blackbody energy, and all stars collapse matter to create radiant energy forms that of course radiate out. These energy forms, be they black body or radiated energy forms, propagate outwards from their source and continue in all directions to fill space itself with a vacuum energy. The easiest drawing for vacuum energy is the one titled on the right hand side at the top, where it illustrates a point source, in this case matter, radiating positive and negative charges in 2 directions. Again, because we have a null space within that matter geometry, there's nothing inside that matter. However, the radiated energy forms from other sources will impinge upon that matter geometry and seek to equalize the energy within it. In this case, they're drawn as the green spherical geometries representative of energy densities of vacuum energy throughout the universe. So every matter geometry in the universe, once it forms, creates a null space within its geometry, and that null space creates a region of low energy density or zero energy density within its own standing wave geometry. The universe, under Tetryonics law 2, will always seek to reach equilibrium. So it will impinge upon the matter geometry and seek to annihilate or fill the volume of matter and equalize it out. However, because of the tetrahedral geometry of tetrons, this is near impossible except under extreme circumstances of pressure and heat, things like that. All these fields where they interact between forms of matter or forms of charged matter, standing wave charge geometries or neutral matter geometries, all do so by superpositioned equilateral geometries or fields. These fields, when they're superpositioned, obviously have a diamond-shaped geometry, which is the inverse square law. This will start to be revealed further and further as we investigate quantum gravitation, and you'll see in fact that Newtonian gravity and Coulomb's constant, which have the same formulation, do in fact follow the same geometry so far as their field interactions. However, in the case of gravity, there is no physical field like there is in the way of Coulomb's constant. There is a vacuum energy between the two. This page simply explains the ether which Einstein sought to banish with special and general relativity by defining the speed of light to be a constant, and that the geometry of matter, or specifically charged shapes, charged particles, would distort due to their velocity to create magnetic moments and similar in order to solve the moving magnet conductor problem. Tetryonics in electrodynamics undermines this foundational assumption of relativity and then goes on to replace special relativity in its geometry with the geometry of equalized or equilateral energy. The ether in this case is reintroduced as the vacuum energy that is radiated or created by the radiated black body and photons and charges of stars and the like. This energy is everywhere. We don't notice it because we're accustomed to it, just as a fish is accustomed to swimming through the water that it swims in. It's around us, it constantly bathes us, and within that system, energy is constantly being introduced or turned back into standing wave geometries and excluded from regions of space. Of note is the fact that while there is vacuum energy, the vacuum energy is not necessary to propagate electromagnetic waves. The waves will pass through the vacuum energy, adding to its energy density in any region, but it's not a firmament or not a medium that is required for the propagation of light from one point to the other throughout the universe. In fact, the vacuum energy or the ether itself is simply what remains of energy that has propagated through space between objects and that has not been absorbed. It's radiated down to a base background energy. There's many more notes on these pages. You'll note them as we go through. I encourage you to go back and look at the pages one by one by yourself over time in the various ebooks. These talks, these public lectures, are simply an introduction, in my own words, to Tetryonics and what I'm explaining in the pictures as I would explain them. Obviously now, any measurement of energy per c squared is a planar measurement, or per square meter, so it's a measurement of mass, as opposed to a measurement of energy density per cubic meter is a measurement of matter. Do note that even though we can measure cubic meters as c cubed. We choose, as we've mentioned before, to measure them as c to the fourth, purely because it becomes far simpler to rationalize the equations when we start dealing with gravitational interactions. So all of radiated mass from standing wave matter geometries fill the regions of space throughout the universe, and obviously close to sources where they're radiated from, be it black body or be it from stars, where vast amounts of energy are radiated every second or every unit of time, we will have differing energy densities, which can be mapped as energy densities in space or mapped exactly as we do on Earth with pressure gradients in the atmosphere. Again, we note that the ether itself, or the vacuum energy, does not facilitate the transmission of energies throughout the universe. It is simply the energy that remains, or the result of radiated energies throughout the universe that have not yet impinged upon matter geometries in order to form higher energy levels of that matter, or again have been excited back up through various other means. But in all cases, following the second law of Tetryonics, energy in all its forms will seek equilibrium. In the case of a vacuum energy, it will seek to equalize the null energy within matter geometries of mass. So a high energy source, such as a star, indicated on the left-hand side at the base of the page, will radiate energy out in all directions to form vacuum energies, and likewise until it impinges upon matter, in which case the matter will always have a convergent or an attractive force due to the matter content of the standing waves. The zero or the null spaces within each matter geometry all add up accumulatively as the elements are built up into larger and larger formations of matter, and as the matter geometry builds up, so does the force that it creates of zero energy, which will try to be equalized by the external ether energy or vacuum energy. You can redescribe the ether again in another form. This happens constantly throughout physics, predominantly in the last 30 or 40 years, where mathematics has strived to find new paths without understanding the geometry that first created that mathematics. In this case, the Higgs field, as promoted by Professor Higgs, is simply just another rewording of vacuum energies or the ether. If you have free space as defined in Tetryonics, you have no energy in any form within that space. That does not occur naturally in the universe except inside Tetrayonic matter. So the Higgs field is just another rewording of the ether, most likely done that way because when Einstein introduced relativity, which was tested by various means and proven to be reasonably accurate in its mathematical descriptions of gravitation, the scientific community were loath to accept articles that mentioned the word ether for fear that it would contradict what Einstein had done with his work in general relativity. In fact, in the later years, Einstein began to refer to the ether again as he sought to develop a unified field theory for gravitation. Again, ether, Higgs field, vacuum energy, they're all words for the same thing, and that is just radiated energy throughout the universe, forming a background field of energy. The Higgs Boson itself, which the CERN's Large Hadron Collider has been seeking to find, and physicists, despite their announcement, are still somewhat confused as to whether they have or have not found it, is in fact, in Tetryonics, just a charged fascia of matter. All matter, for example, a tetryon has 4 charged sides, as drawn on the right hand side of this picture. It forms the quanta, or the quantum of matter. Has 4 sides, each of them charged. You can reterm these charged fascia as Higgs bosons. Because they are a single equilateral geometry, they fall in the definition of a boson, i.e. they're an odd number. They contain charge because they are an odd number, so therefore they're a boson. By virtue of the fact, as illustrated in the middle, they're all squared energy geometries, and the electromagnetic energy geometry or scalar geometry of that square energy can in fact be represented as a idealized quantum inductive loop, where if you were to short circuit a superconducting inductor into a triangular geometry with the tails touching at the apex where the V is in the case of this boson, you would create a magnetic dipole of north-south arrangement dependent on which way the energy flowed in that circle, in that inductor. You can see that direction is indicated here as the naught epsilon naught and mu naught vector rotation. This vector rotation is purely to illustrate how a equilateral energy geometry, square energy geometry, can in fact be drawn or viewed as a quantum, an ideal quantum inductor, in which case the direction of flow will create a positive or negative charge as measured by the direction or the magnetic vector of the dipole created. And in fact, just like the short-circuited inductor, the equilateral geometry of energy resists changes to its energy levels. To increase or decrease the energies, as highlighted in electrodynamics, you have to add specific odd-numbered bosons to the energy geometry, and that requires work in order to add or release the energy within the same time measurement or within the same mass. Hence, equilateral geometries of bosons, single bosons, can also be described as mass, and they give the inertial description of inertial mass through their geometry, which can also be redescribed as a short-circuited quantum inductor. So pi geometries that form each charged fascia of matter can be described as Higgs bosons, and their energy geometry is what gives inertial mass to matter as it moves through the surrounding vacuum energies. So using Tetryonics, we've gone from what was explained in quantum mechanics of the square energy fields being equilateral geometries. We've given the physical basis for inertial mass, and we've also defined matter as a tetrahedral geometry. All this combines to give us clear evidence and a clear foundation that the ether exists, and that inertial mass is simply a property of the charged geometry of matter moving through its surrounding energy field. A stylized version of the Higgs boson, again highlighting that in the particle field geometry of all subatomic particles, from the 0-point fields of electric charge or 0-point fields or 0-point energy, as illustrated at the top with one charge either side of them, we can build all the subatomic particles that exist in the universe, and including all the macroscale objects of matter such as stars, planets, ourselves, from charged geometries. Every form of matter is comprised of charged or neutral tetrons and gluons. All of these standing wave geometries can be redescribed in current terminology as a Higgs boson. Tetrons have 4 Higgs bosons. Quarks have 12, although with the case of quarks, only 8 of those 12 are present to the external world for measurement. In the case of leptons, again with 12 charged geometries, all 12 are presented or are able to be measured and impinged upon by vacuum energies. In the case of baryons, there are 36 pi charge geometries, of which only 20 are presented for measurement or interaction on the outside world, creating inertial mass. The other charged geometries combine together in the strong force within the nuclei to hold the nuclei together, or hold the tetryons together to form the nuclei, the geometry of that specific matter form. Electromagnetic mass energies on this page. This page just simply gives you the formulation, or the formula, for all mass energy matter geometries using the unified Tetryonic field equation. 1 pi being a boson, or specifically charge. It's referred to also, as we've just mentioned, as a Higgs boson. Odd numbers, obviously 1 being an odd number. All odd numbers are bosons in general. Photons are 2 pi, occasionally referred to as tau pi geometries, or just tau geometries. Again, even numbered waveforms, or even numbered mass energies, electromagnetic waves comprised of tau geometry photons. Energy itself is just n pi. It's just the number of equilateral energy geometry that make up any form of mass or matter without any corresponding measurement of time or spatial geometry attached to that that energy form. It's the generic form, if you like. We then define matter, again naturally, as 4n pi, or t pi, tetrayonic geometries, as being, or tetryon being comprised of tetryons, which are 4 pi geometries, or tetrahedral geometries, again measured in c to the 4th spatial geometries. We can then describe quarks and leptons as 12 pi geometries, baryons as 36 pi geometries, and the quanta of elementary particles, or deuteriums, as 84 pi geometries. Any multiple of 84 pi, 2 times 84 gives us helium, so on and so forth. 92 times 84 will give us uranium. Deuterium is the building block of all the periodic elements. So again, we've defined mathematically through the unified field equation the mathematics, and distinguish between mass energies, or mass, energy, and matter with the spatial coordinate systems. We've also geometrically drawn the differentiation between mass, energy, and matter, and we're now completely able to revise Einstein's equations, purely because instead of having just a energy density per square meter or per cubic meter, the stress energy tensor, rho, as Einstein called it, or used in his field equations, we can now clearly define mass itself, energy itself, and matter in all the forms that it can take, and all the strengths that it can take for its interaction at the quantum level, building up to the macroscopic level of gravitation itself. A quick explanation here. You can look at the page in greater detail, but using Tetryonic definition of the exact mass of Planck's constant mass energy content of the geometry, and the matter geometry, or the 4n pi Tetryonic matter geometry of all elements, we can clearly distinguish between the electromagnetic mass content of an object and its matter geometry. The geometry obviously being the standing wave that the mass energy moves in. And in fact, we can have two objects of the same mass matter, or the same mass, having different matter geometries. Avogadro's number obviously plays into that as a mole of each, and how much Tetryonics then uses the charge geometry to show you how much space that mass will take up in comparison to the mass of the other. And we can clearly define, for the first time in history, the distinct difference between mass energy and matter itself in all forms. Again, here we're just highlighting the difference between charged quanta, the frequency or the photon frequency, and quantum of matter. In the case of charge, they're always odd, or in the case of 0-point fields, they're just 1, but they're always an odd number. In the case of photons, they're formed of 2π geometries, not 1, and that frequency of an EM wave is an even number, comprised again of multiples of 2. In the case of matter, it's always a tetrayonic number, or a number that is comprised of 4n geometries. Electromagnetic mass, again explained, just distinguishing again between mass in kilograms and matter in kilograms. And the distinguishing feature is not the mass itself or the energy content. The distinguishing feature is the standing tetrahedral waveform that the energy or the mass energy takes. You can have a photon or a gamma ray of exactly the same mass energy as a proton or a neutron. More likely a neutron because it won't be charged. They will have exactly the same mass energies. However, in the case of the neutron, it will be a matter geometry. In the case of the gamma ray, it will be a electromagnetic mass geometry. There are no such things as massless photons or EM waves. They all have mass energy. All the mass energy within the universe follows the equilateral or square geometry of Tetryonics. As you'll note there, and has been mentioned many times, the quantum levels, reading from left to right, of any triangle are comprised of odd pi geometries, bosons. These bosons come together sequentially, or in sequence, to form square energy levels, equilateral geometries. And the total equilateral geometry is the quantized angular momentum of any system. Again, if you have a charged matter geometry, say a lepton, you have 12 quantized angular momentum, or 12 charges, creating that geometry. In the case of all energy geometries, the energy quanta come together in such a way within that equilateral geometry to create a even or a normal distribution of energy within that equilateral geometry, and that creates the familiar bell curves of quantum electrodynamics, the statistical probabilities of EM waves, their wave functions, and the like. A lot more of this is covered in quantum electrodynamics, but it forms the foundation of all mass energy within the geometry. If you were to view this equilateral triangle as the Higgs boson, you would have one charged fascia, and the Compton frequency, or the number of quanta within this charged geometry, is what gives matter its mass and its solidity, not the repulsion of electrons between matter. It is matter itself and the energy within that geometry that makes matter solid and heavy in gravitational fields. Without the gravitational field, it just has inertial mass. Again, highlighting the energy densities on the side of all matter. Each matter geometry, or in this case a tetryon, has 4 sides, and each of those sides has square energy levels. The Compton frequency, or the number of quanta per fascia, is what gives the mass to matter, i.e. its mass energy density for that particular particle within every spatial measurement of time or region of space. Care always has to be taken when seeing energy density per cubic meter to make sure that you're measuring it in c to the 4th, not c to the 3rd. Again, highlighting using the distinction between mass and energy. In this case, normally given by Einstein as formulation of mass is energy per c squared, or per second, a measurement of energy per second. Using Tetryonics, we can see the difference. In the case of electromagnetic mass, we have n-pi geometries in that region of space. The space itself is per c squared, or we're measuring the electromagnetic content of the energy, Planck's constant, mass, angular momentum, per quanta, or scalar mass, velocity squared. Either one, it remains energy. So, in the case of mass, as defined in Einstein's formulation, mass is electromagnetic energy within that region of space, the c squared. In the case of energy itself, we have no time measurement. You'll note that the electromagnetic component is gone, and it's now purely the Planck quanta, or the scalar mass, by its velocity squared within that same region. All of these can be applied as illustrated in the middle. All we're determining the difference between electromagnetic mass and energy is the fact that we're determining the electric permittivity and the magnetic permeability of that energy. And we do that by taking a time measurement and measuring the flux of the fields within that geometry, within that time geometry. The energy momenta of particles is often referred to in relativity. In this case, a tetryon has 4 pi mass energies. The square root of any energy geometry is its linear momentum. So therefore, the 4 pi geometry of any matter quanta or tetryon has 4 linear momenta directions. And if you follow those linear momenta directions, they in fact are the square root of the E field as it propagates to the end of a magnetic dipole in each case. And the energy from the magnetic dipole then gives energy back to the electric field. So in any tetrahedron matter or tetryon, the energy is in a standing wave formation where the energy circulates at the speed of light, at the natural speed of energy. It's not the limit, it is just the natural speed that energy propagates at as a relationship between its frequency and the wavelength of the energy within each geometry. Of course, were you to collapse the standing wave geometry of matter, rest matter, into a radiant mass energy form, 4 pi radiating energy, these 4 energy momenta will line up in the same direction with one opposing, 3 one way, 1 the other, and the radiant energy, in this case a boson, would radiate off, and its mass energy content would, because it was already propagating at c because of its frequency wavelength geometry, would give us E equals mc squared. The formula of equivalence made famous by Einstein happens to work in the case of charge or energy and photons radiating through space, and it happens to work in the case of matter being converted into energy. Obviously the relationship between mass and energy being c squared, and likewise the relationship between energy and mass being c squared by virtue of the time measurement. We will always get E equals mc squared, and this has been taken by physicists since that formulation to be the limiting factor for the velocity of energy. In fact, if you increase the energy content of the energy greater than c squared when it radiates out in a second, you will in fact exceed the speed of light, and this is shown through the geometry further on and in further detail in the rest of the cosmological book on Tetryonics, book 4. All these relationships between Planck's constant, mass, Compton frequency can all be redrawn in this simple formula here of 2 opposed bosons, a positive one upwards, a negative one downwards, with matter in the center surrounding it. to illustrate matter surrounded by or radiating out bosons or energy waveforms and being impinged upon by the same energy waveforms radiated from other sources. This brings us to defining the tetration as the quantum for all gravitational matter. The tetration being the first standing waveform of that energy can create that has a volume and has a null, and in the process creates null space within its geometry. The creation of this null space then creates a quantum of matter where the vacuum energy surrounding it seeks to equalize that energy by pushing inwards on that geometry. That convergent force inwards is there at all times while the matter exists, irrespective of its mass, and is what we call gravity. It's important not to mistake the word gravity for gravitation. Gravitation will be revealed to be a three-field effect, whereas gravity itself is purely the convergent force created by vacuum energies as they seek to equalize the null space within all matter geometries. As I mentioned, the convergent vacuum energy impedes upon the mass energy geometry of matter. In doing so, it creates what we measure as gravitation, as gravity. The energy itself is measured per c squared because it is mass energy. It's a planar energy form, whereas matter within the same volume of space is measured with c to the fourth because it is a tetrahedral or matter geometry. We can then start equating the specifics of mass and matter and energy itself and the gravitational pressure gradient that is created when you form matter back to the curvature of space-time used in Einstein's general relativity and to the word used in Newtonian formulation of gravity, or the force of gravity, which of course is remarkably similar to Coulomb's electric force between charged particles. In all cases, what we're doing, as highlighted by Einstein, is we're taking a pressure measurement of energy within a unit of time, in this case c to the fourth or seconds squared, but whereas Einstein took a measure of all the energy and lumped it into just a stress energy tensor T, as highlighted here in both cases, what Tetryonics does is it goes one step further to distinguish between all energy forms that are measured and the energy forms and geometries of mass, energy and matter within that region of measured spatial geometry. Again, all quanta of matter, tetrons and upwards, radiate energy out. Firstly, they'll have a charge, which is the strongest form of energy. It interacts to form between tetrons to form larger and larger scale matter, up to elements and stars. They radiate blackbody energy as light and heat, and again that radiated energy spreads out throughout the universe from its sources to form the vacuum energy, or the background energy, the ether of the universe, which then again spreads until it impinges upon gravity, or upon matter geometries to create the force of gravity. You can, if you wish, and in fact this is what Newton did with his math, you can, upon looking at energy geometries, you'll note that energy geometries have a divergent charge geometry and a convergent opposed energy momenta within that charged geometry. So far as an equilateral geometry or photons go, there are more divergent energy momenta than there are convergent energy momenta within the equilateral geometries. We can strip away the divergent component of all energy geometries, and in the case of a inverse squared or diamond geometry, we can then use the convergent energy direction or energy momenta directions as a model for the convergent force of gravitation. It does, even though it accurately models the field, the convergent field of gravity on a body, it does not explain the source of that convergent force. And that's exactly what Newton did. He mathematically modeled the convergent force of gravity between two bodies, a diamond-shaped field, and got the solution with his mathematics. However, the mathematics did not have the geometry, nor did it have the standing wave explanation of equilateral energy in order for him to form a hypothesis on what created that convergent force. Hence his famous statement to that effect. But you will find that using Tetrayonic geometry, you can model both Newton and Coulomb's inverse squared laws for gravity and charge alike. Obviously, all matter geometries with their mass energy content in a gravitational field will create weight. Weight is a measure of the matter geometry. Historically, it's been always termed as the mass of an object. It's more appropriately the mass matter of the object. There's a number of terminologies that you'll come across in Tetryonics that flow out of the strict definition and distinction between mass, energy, and matter. There are no such things as massless photons. All photons have mass energy. And likewise, in a gravitational field, it is the mass energy content of matter that draws things down to the surface of the gravitational matter, as opposed to gravitational mass as it's historically been termed. Again, using the equilateral geometry of Tetryonics, we can quickly refresh on 0-point fields being equilateral geometry, and the charge of those fields being the result of the quantized angular momentum or the equilateral geometry per unit of time. They all contain square quantas. However, the square quantas come together in a convergent and divergent arrangement in each field, as indicated here on the bottom in the electromagnetic fields. There are square quanta in both of these fields. However, in the case of the negative field, there are more negative divergent charge quanta than there are positive. And in the case of the positive field, there are more positive divergent energy quanta than there are convergent negative quanta. These can be represented as circular sources of fields. In the case of the negative one, it is the negative field that diverges out. Whereas in the case of the positive, it is the positive field that diverges out with the negative travelling inwards.